We now discuss the solution of a problem from the section Complex Analysis. The problem is related to Open Mapping Theorem, and this question has appeared in the CSIR National Eligibility Test held on 16th September 2022, and it is from the part C, multiple select question, and it carries 4.75 marks. The given question is for an open subset omega of the complex plane C such that 0 belongs to omega, which of the following statements are true? We are given four options. Option 1, the set consisting of e power z where z belongs to omega is an open subset of C. Option 2, the set consisting of mod e power z where z belongs to omega is an open subset of R, the set of real numbers. Option 3, the set consisting of sin z, z belongs to omega is an open subset of C. Option 4, the set consisting of mod sin z, z belongs to omega is an open subset of R, the set of real numbers. We are given an open subset omega of C such that 0 belongs to omega. Then we have to discuss the validity of the following four options given. And it is the question from part C. There can be more than one answer. Let's now discuss the solution of the problem in detail. We have that omega is an open subset of the complex plane C and 0 is an element of omega. Let's now discuss the validity of the statements that are given in options 1 to 4. And we first consider option 1. That is, it says the set consisting of e power z where z belongs to omega is an open subset of C. We have omega is any open subset of C. Agreed? Now let f of z be e power z, z belongs to C. Now notice that f of z is equal to e power z is a non-constant analytic function. Now let us recall the famous open mapping theorem. It says a non-constant analytic function maps open sets onto open sets. Right. So now by open mapping theorem, f of z maps open sets onto open sets. That is, f of z maps open set omega onto the open set f of omega. So it says, therefore, f of omega is equal to the set consisting of f of z, where z belongs to omega, is the set consisting of e power z, z belongs to omega, is also open subset of C, because omega is given to be an open subset of C, and f is a non-constant analytic function. By open mapping theorem, it maps open sets onto open sets. So the omega, the open set, is mapped onto the open set f of omega. So that's f of omega, that is the set considered e power z, z belongs to omega, that this is the one, is an open subset of C. Thus our option 1 is true. Agreed. We move on to the next option. Option 3. The set consisting of sin z, z belongs to omega is an open subset of C. This is also true, and it follows on the same lines of the option 1. Now we have omega is any open subset of C. Let g of z is equal to sin z, z belongs to C. And notice that g of z is equal to sin z is a non-constant analytic function. Therefore, by open mapping theorem, it maps open sets onto open sets. Agreed. So G of omega, by open mapping theorem, G of z maps open sets onto open sets. This implies G of omega is open, is equal to the set consisting of G of z, z belongs to omega. That is, the set consists of sin z, z belongs to omega, is also open subset of C, because omega is open. Therefore, G of omega is also open. Because G is a non-constant analytic function, it follows by the open mapping theorem. Therefore, option 3 is also true. Move to the next option, option 4. That is, the set consisting of mod of sin z, z belongs to omega, is an open subset of R, set of real numbers. So we have omega is an open subset of C and 0 belongs to omega. This is very important. This is important here. So now let A is equal to the set consisting of mod sin z, z belongs to omega, is a subset of R. Why? Mod of sin z is a real number. Right, agreed. Note that 0 belongs to A. Why? Because 0 belongs to omega. So 0 belongs to omega. Mod of sin 0 is 0. 0 belongs to A. Very simple. Right. Further, A is equal to the set consisting of mod sin z, z belongs to omega, is a subset of R plus positive real numbers union 0. That means it is a subset of this non-negative real number, set of non-negative real numbers. Agreed. Note that any epsilon neighborhood of 0, however small, epsilon b. What is epsilon neighborhood of 0? 0 minus epsilon to 0 plus epsilon, the open interval. And that is not entirely contained in A. Not entirely contained in A. Why? Because the portion 0 minus epsilon to 0, the open interval, that is minus epsilon to 0, consisting of all negative real numbers. And that should be contained in A. That's not possible. Because A is contained in the set of all positive real numbers union 0. So it doesn't contain any negative real numbers. So therefore, note that any epsilon neighborhood of 0, however small, epsilon b, is not entirely contained in A, because A is contained in R plus union 0. Right. So that means this says 0 belongs to A, but 0 is not an interior point of A. So if 0 is not an interior point of A, then it's not an open set. Because what is an open set? Every point of the set is an interior point of that set. But here it is not. Now A is equal to the set of a mod sin z, z belongs to omega, is not an open subset of R. So therefore our option 4 is not true. Let's move to the option 2. That is the set consisting of mod of e power z, z belongs to omega, is an open subset of R. Now, the set consisting of mod of e power z, z belongs to omega is equal to, writing for z x plus iy, it is the set of all mod of e to the power of x plus iy, where x plus iy belongs to omega. And this is equal to the set of all mod of e power x into mod of e to the power of iy, where x plus iy belongs to omega. And mod of e to the power of iy is 1. Agreed. So mod of e power x is just e power x because e power x is always positive. Right. This is the set of all e power x where x plus iy belongs to omega, and this is a subset of R because e power x for x belongs to R is a real number. Agreed. So that is the set consisting of mod e power z, z belongs to omega, is equal to the set of all e power real part of z, because e to the power of x we have got. What is x? X is the real part of z where z belongs to omega, and it is a subset of R. It is a subset of R, and let A is equal to the real part of z where z belongs to omega. So let f be a mapping from R to R, be a function defined by f of x is equal to e power x. And notice that f of x is equal to e power x is a monotonically increasing and continuous function, and it maps open intervals onto the open intervals. It maps the open subset, open interval a comma b onto the open interval e to the power of a comma e to the power of b. This we will be using later in this discussion. Now, the set consisting of mod of e power z, z belongs to omega, is equal to the set consisting of e to the power of real z, real part of z, z belongs to omega, that is precisely equal to the set of all e to the power of x, x belongs to a, where what is a? A is equal to the set of all real part of z, z belongs to omega, and that will be equal to f of a. Required to prove that this is open in R, that means f of a is an open subset of R. So first we claim that our set A, that is the real part of z, z belongs to omega, is an open subset of R. So for that, let us take alpha belongs to A. So we want to show that every point of A is an interior point of A. For that, we have taken an alpha, an arbitrarily chosen element of A. So alpha belongs to A means alpha is equal to real part of z for some z belongs to omega. Then there exists a point, there exists a z naught belongs to omega such that the real part of z naught is equal to alpha. Agreed. And what is omega? Omega is open subset of C, and z naught belongs to omega. So z naught and omega being an open set, every point of it is an open, is an interior point of it. Therefore, z naught belongs to omega will imply z naught is an interior point of omega. Z naught as an interior point of omega means there exists a neighborhood which is entire neighborhood of z naught which is entirely contained in omega. So there exists a real number delta z naught, delta suffix z naught, that means the delta depends upon z naught which is positive, such that the neighborhood with the center z naught and the radius delta z naught is entirely contained in omega. So this is the neighborhood, and the z naught is the center, delta z naught is the radius. Agreed? Agreed. Let D be the set of all points on the diameter of this neighborhood joining z naught minus delta z naught to z naught plus delta z naught. That means all the points that are lying on this diameter connecting z naught minus delta z naught to z naught plus delta z naught. And that is entirely. So let D be the. So where will be the D? D is entirely contained in this neighborhood. So then D is contained in the neighborhood with the center z naught and the radius delta z naught, which is entirely contained in omega. Great. Now the neighborhood with center z naught and radius delta z naught is entirely contained in omega. Take the real parts on both sides. So the real part of U, where U belongs to the neighborhood, is entirely contained in the real part of V where V belongs to omega. And this is precisely equal to A. This is precisely equal to A. And just now we have seen D is entirely contained in omega. So the real part of that is also entirely contained in that one. Further, the real part of the real part of the elements of delta. In that you take the extreme points Z0 minus delta Z0, Z0 plus delta Z0. And the real part of this and the real part of this, connecting that one, is the interval, open interval. So that is the real part of Z0 minus delta Z0, comma, the real part of Z0 plus delta Z0 is a subset of D, and D is a subset of this one. Therefore, this is entirely contained in the real part of U. U belongs to the neighborhood, which is entirely contained in A. So that means this means real part of Z0 is alpha minus the real part of delta Z0 is delta Z0 only, because delta Z0 is the radius, which is a real number. So this is the open interval alpha minus delta Z0 to alpha plus delta Z0, which is entirely contained in A. So that means we have taken an alpha belongs to A, and we have now found a neighborhood of alpha, which is entirely contained in A. That is, alpha is an interior point of A. How alpha is chosen? Arbitrarily chosen. So therefore, every element of A is also an interior point of A. So this shows that A is open subset of R. Now let's continue, and we have this one, and we have proved A is equal to the real part of Z belongs to omega is an open subset of R. We have just now shown. We make a claim 2. This f of A is open. If f of A is open, then the set consisting of mod e power Z belongs to omega is an open subset of R, and hence thus option 2 will be true. So how do we prove f of A is open? So it is known that every open subset of the set of real numbers is a countable union of disjoint intervals. Disjoint open intervals. It's not disjoint interval, just intervals. Disjoint open intervals. Open intervals. Right. And what is A? A is the open subset in R. Therefore, by the above, A is the disjoint union of open intervals. That is, union n belongs to n, countable union, n belongs to n means countable union of in are open interval. In is an open interval. So, where ii intersection ij is empty when I not equal to j. That means they are disjoint. It's a disjoint union of open intervals. Countable union of disjoint open intervals. So now operate on f of A is equal to f of the union of the intervals is equal to the union n belongs to n f of in. Why? Because they are disjoint. It's a disjoint union. That is why f will come out like this. And what is in? In is an open interval. What is f? F is a exponential function. It maps open intervals to open intervals. Therefore, f of in is also an open interval. So therefore, f of A is a countable union of open intervals, because f of in is an open interval. So f of A is a countable union of open intervals. Therefore, f of A is open subset of R. So thus f of A is an open subset of R. So what is f of A? The set consisting of mod of e power z belongs to omega is an open subset. That is, f of A is an open subset of R. Thus we have proved that the option 2 is also true. So summarizing all the options, the answer to this question is option 1, 2 and 3, and option 4 was not true. That is the detailed discussion of the solution of the problem from the section complex analysis, and it is based on open mapping theorem. And it is definitely an interesting question and an important question also. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.